Hi everyone. So for today's class, we're going to look at how to sketch a quadratic function as well as its modulus. Now, modulus is basically kind of like the two vertical lines that contain the fx. So we call it the modulus, or sometimes we call it the absolute value. Now, don't worry about what it means. We will definitely go through that later in this video. Right now, we're going to focus on how to sketch a quadratic function. And in this example, I've given that fx is equal to x squared minus 3x minus 4. And we want to sketch this particular quadratic function. Now, we know that quadratics can be either a U-shape or N-shape. And in this case, this is a U-shape. And the reason is very simple, because the coefficient of the x squared here, which is 1, is a positive value, so it is more than 0. So we therefore know that it's going to be a U-shaped parabola, and we do expect to sketch that shape later on. Now, there are 4 things you need to have before you can sketch any quadratic function. First, the roots, or we call it the x-intercept, right? Now, there are a few ways to get the roots. You can use quadratic formula, you can factorize it, equate to 0, and solve, or you can use any other strategy, split the middle term. All right. Now, we also need the y-intercept, and the y-intercept is essentially the constant term at the back of any quadratic expression, like in this case, a minus 4. Now, we also need the minimum and maximum point, or the vertex value. We can do that via a few ways. Yeah, we can use, of course, completing the square, or x equals to minus b over 2a to get the x vertex. And yeah, the last one is the shape, which we talked about earlier on. Now, once you have these 4 particular parts, we can therefore get to our sketching. All right, so let's factorize first. Let's get the roots out. So if we factorize this, x minus 4, x plus 1, and if we equate to 0, our 2 roots is x equals to 4 and x equals to minus 1. So at least now we know the x-intercept, right? All right, that is very good information. We need that. All right, the next thing is we want to get a y-intercept, and like I mentioned, it's just basically the value at the back of the quadratic expression. So our y-intercept is 0, minus 4. Now, the next thing is we need the minimum maximum point. We know this is a minimum because it's a U-shaped parabola. So we're going to use x equals to minus b over 2a to help us to get the x vertex in a quick time. All right, so minus b over 2a, we work that out. So it'll be minus bracket minus 3 over 2 times 1, which leads us to 1.5. So that is our x vertex. And we still need to find a y vertex, so we're going to substitute 1.5 as the x value into the entire x squared minus 3x minus 4. And we're going to do that, and let's see what is our y value. If I try to work that out, okay, I think it's something around 6.25. Yeah, I believe that is so, 6.25. Negative. Yeah, negative. All right. So with that, we are done, and the shape is U-shape. All right. So we have all the 4 information that we need, and we go ahead and draw our x and y axis. Make sure you label x and you label y. Don't forget that. Now in this case, because it's a function, we label it fx instead. All right. So let's key in all the key information. Our roots first, we put it there. Our y-intercept, which is negative 4, and our vertex coordinates, and that is 1.5 and minus 6.25. All right, we're going to put that down, and remember the vertex is just like a dot right at the middle of the parabola. It's kind of like the symmetrical point, or a line of symmetry can be drawn at x equals to 1.5 to cut the parabola into 2 equal parts. Now, so I have that. I will put it all together and I'll do a quick sketch of it. Oh, not a V shape, it should be more like a U shape. Let me try again. Yeah, I need to make sure I cut through all the key points. All right, yep. And then I'll just turn it up. There you go. All right. So that will be your parabola of the x squared minus 3x minus 4. So with this 4 information, it's very important. Once you have it, you can definitely sketch your quadratic function. Alright, so the next question is then, okay, so what is a modulus version of fx? What do you mean by to find the absolute value? Very easy. Basically is whatever of the graph that is below the x-axis, in this case the one that I've shaded, which is that part, that entire part will get reflected above the x-axis. It will get reflected above. So if I'm going to try to draw the modulus fx function, you will see that I will draw exactly the same at the above the x-axis. Nothing's changed. The roots are still the same. Okay, but my minimum point, my local minimum point, will end up becoming at the top, and my y-intercept will also get flipped up above as well. So my roots hasn't changed. So roots are still the roots, and this will be my new eventual local maximum. Alright, and before was minus 6.25, now it's positive 6.25, but still at x 1.5. And notice that it looks like an N-shaped part, just only at the part where I reflected it. And then from 4 onwards, it's still the same function, hasn't changed. Alright, so this is what I mean by a modulus function of fx. I reflect everything below the x-axis above. There you go. So that's a reflected component. Alright, so that is how you sketch your modulus fx. So there's really nothing below the x-axis once you do a modulus. Alright, now some of you will also wonder, okay, what happens if it's an N-shaped parabola? Then what would it look like? Right, so we're going to look at an example if we have an N-shaped parabola, and which part do we actually reflect? Yeah, it is actually the same idea, and the shape would look almost like a usual modulus function graph. Alright, so let's try a negative parabola or N shape. Alright, the roots are still the roots, nothing's changed, but what we're going to reflect is the fringes at the tail end. So it's going to go up to the left and to the right like that when I reflect it. Okay, so that's really it. That's how you sketch a modulus function. So I hope these examples has been really useful, and you see that you can actually just flip it right up. Alright, so that's all for today. Any comments, please share with me, and I will see you in the next one. Cheers, everybody.